Welcome to the world of physics, the scientific study of matter, energy, and the interaction between them. Physics, with its vast reach, delves into an array of topics including mechanics, thermodynamics, electromagnetism, optics, quantum mechanics, and relativity. It's a key that unlocks a profound understanding of the natural world and paves the way for predictions and technological innovations shaping our contemporary society. One of the defining characteristics of physics is its quantitative nature. It leans heavily on measurements, calculations, and mathematical models to explain and forecast the behavior of physical phenomena. The aim is to formulate precise quantitative relationships between various physical quantities. Yet physics isn't just about numbers and equations. It firmly stands on the empirical basis, relying on experimental observation and empirical evidence to formulate theories and laws. Through meticulous experimentation and data analysis, physicists amass knowledge about the natural world and develop theories that elucidate observed phenomena. The quest of physics is to unearth the fundamental principles and laws governing the behavior of the universe. These principles are universal and apply to a broad spectrum of phenomena, allowing us to comprehend not only the everyday world, but also the intricate workings of the cosmos. One must remember, physics doesn't exist in isolation. It often intersects with other scientific disciplines, such as chemistry, biology, astronomy, and engineering. It lays the groundwork for understanding the behavior of matter and energy in varied systems, and is crucial for advancements in many other fields. The predictive power of physics is truly remarkable. Through mathematical models and theories, physicists can anticipate the outcomes of experiments and even predict phenomena yet to be observed. Physics is a dynamic field in a constant state of evolution. New discoveries, theories, and technologies emerge as our understanding of the universe deepens. The boundaries of knowledge are ceaselessly pushed, leading to advancements and applications in diverse fields. Physics is anchored in a set of fundamental principles.
Picture a universe that operates on a set of fundamental principles, a cosmic rulebook, if you will, that governs everything. These are the principles of physics, the laws that keep the universe in check. They whisper the secret language of the cosmos, the dialect of the natural world. Let's delve into these principles, shall we? First up, we have the conservation of energy. This principle states that energy, that mysterious force that powers everything from your cell phone to the stars, cannot be created or destroyed. It can only change its form, like a cosmic chameleon. So, in a closed system, the total energy remains constant, whether it's morphing from kinetic energy into potential energy, or vice versa. Then we have Newton's laws of motion, 3 rules from the insightful mind of Sir Isaac Newton. The first law, often known as the law of inertia, says that an object at rest stays at rest, and an object in motion keeps moving in a straight line at a steady speed, unless an external force nudges it otherwise. The second law tells us that the force on an object equals its mass times its acceleration, a simple equation that holds profound implications. The third law states that for every action, there's an equal and opposite reaction, a principle that keeps the universe in balance. Next, we have the law of universal gravitation. This principle, another brainchild of Newton, proposes that every particle in the universe attracts every other particle with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between them. This law is why we aren't floating off into space right now. The conservation of momentum, our next principle, states that the total momentum of a closed system remains constant unless acted upon by external forces. Momentum, the product of an object's mass and velocity, is thus preserved, another example of the universe's astounding balance. We also have Maxwell's equations, the brainchild of James Clerk Maxwell. These equations describe the fundamental laws of electromagnetism, explaining how electric and magnetic fields interact and propagate through space. Lastly, we have the laws of thermodynamics. These laws describe the behavior of heat and energy in systems, covering concepts like the conservation of energy, the increase of entropy in isolated systems, and the impossibility of reaching absolute zero temperature. In summary, these principles, from the conservation of energy to the laws of thermodynamics, provide the framework for understanding and analyzing the physical world. They form the basis for theories, models, and practical applications in various fields of physics. They are the cosmic rulebook, the fundamental laws that govern the universe and everything within. And as we continue to explore and understand these principles, we get one step closer to deciphering the secret language of the cosmos.